Not required to, but if you have access to it and would like to follow along, we're currently in the OneNote file of the Modal Node System, MNS, presentation 1224, OneNote, inverted modal distance, finish lap versus inverted intervals, return trip. We have the list of presentations on the right, which we plan on adding plenty more to shortly. Also note that within this OneNote presentation, we could spend all of our time focusing in on music theory, but we have a similarly numbered and named presentation as well, where we build these tables in Excel, practicing our music skills, our Excel skills, and our table visualization at the same time. We're going to be continuing to look at our interval notation, this time thinking about directionality, which is a very vexing problem for many people. I'm sure you've run into it. I'm sure this has caused you problems, even if you're not aware of it. Let's get our analogy in place before we get into it, because remember, the terminology is going to get a little wonky here, particularly when we're going in a negative direction. Therefore, we don't want the terms to throw us off from our end goal. Remember the objective. What's our objective? I would say for most people, it's to be able to visualize the fretboard, navigate it as cleanly and easily as possible. To do that, I need to have directionality terms that are as clear as possible. Unfortunately, the ones that we use are not as clear as possible. Therefore, I need to be able to use the terms we have in a way that's efficient, even though they might be like talking to a sneaky lawyer or sneaky professor or something that basically insinuates things that pulls you out of the optimal way to visualize the fretboard. Don't let that happen. Stay focused. Stay focused. What is the best way to visualize the fretboard? Well, it's a map of the territory. It basically is a territory. It's got 7 destination continent type locations, comparing it to a globe. It's got 5 non-continent locations, which I'm going to say are the oceans. Those are the ones that we go through to get to the destination continent locations, of which there are only 7. Our head is up here in space, over the fretboard, over this low or heavy E string, the one closest to the ceiling, and we visualize the fretboard spinning around like the world is spinning around, assigning it 12 different degrees of rotation, which we label based on the 12 notes in the musical alphabet. We're typically going to be working on the 4th degree of rotation, which we call the collection of notes around the C major scale, but that's just a convention. We could go to the C sharp, we could go to the D sharp, and all of the relative positions would be the same. Just like you copied and paste, just like the continent planets rotating around don't change as you rotate it. Once you determine what degree of vision you're looking at, you no longer want to measure the fretboard primarily by the note names, but rather by the continent names, the things that don't change. And that would be similar to a Nashville number system if you use that, which is basically a modal system, just replacing the modal names with numbers. So the 1 is the Ionian, the 4 is a Lydian, the 3 is the Phrygian, the 6 is the Aeolian, and so on and so forth. Now the problem is that our naming conventions are based on scale degrees. Scale degrees are kind of measurement tools that are off by 1. Right? That's the problem. So it forces us to kind of think that we need to rename certain continent positions because of the tool being used that should simply be directionality. So let's think about that for a second down here. If we had our globe down here, we have all of our continents. So notice down here, I can go across the middle and so on and so forth. So I might get from North America to Asia by doing multiple different things. I can go around this way, or I can go straight across, and so on and so forth. But in our analogy, we can take the string here and imagine we wrap it around in a circle. So we only have a lap. We have a racetrack. It's an oval. We can only go around one way. We can only go around it. We could go around directionality, however. So although I can't go through the middle here, I could go clockwise and I could go counterclockwise. So if you were to construct a system of a map that is built like a racetrack, then the directionality terms that you need is either it's going forward or it's going backwards, and then the units of distance, which in our case are going to be notes or it could be the 7 notes, which would be the modal half steps, the continents versus the continents and the oceans. That's all you need. I don't need to say, hey, look, take a left at the gas station, take a right at the school. No, because I'm on a racetrack. All you could do is go around clockwise, or you can go around counterclockwise. Now later we will add the idea of octaves, because there is such a thing as octaves, so it is more complex in that when you keep on going around clockwise, you're also going up pitch-wise. You're going up octave-wise. So the pitch is the same, or it's the same key, but it's also getting higher in the pitch. Okay, we'll talk more about that later. Right now, we're just visualizing it as a racetrack, and we're going to introduce the idea that we can go around the racetrack to the right, and we can also go around to the left. So the analogy, we're on the 2 here. We name that the 2 means South America. The name of it is 2 for us. And if I'm going to the 5, how far is that? I can go 1, 2, 3. It's 3 continents up. Or I can name this as the 1, which makes me rename it, which isn't proper for a measurement tool, right? 1, 2, 3, 4. That would make it the 4th. Or I can name the oceans as well. So now I'm going to go 1, 2, 3, 4, 5. It's 5 up. That would be equivalent to the notes or the half steps that would be up. But that's not the only thing I could do. I could go backwards. I could go 1, 2, 3, 4, -4 modal half steps backwards. Now, you would think that that would be, if I made this the 1, it would be 1, 2, 3, 4, 5, -5th scale degree backwards. But we don't usually do negative scale degrees. That's the problem. We don't really have directionality in the current system. And part of the reason for that is because it's clear that it becomes a mess because the measurement was off, right? So let me show you what I mean.